Okay, so welcome. This is the Soft Bodies Studio, Weak Buildings. These are students who generally have they're in the master's program and they have like a year left in their studies generally. And today we're kind of gonna look at Blender as a software to help support you and the rest of the studio. And we're joined by Ian Erickson, who you've seen on the internet before, and now is here in person. Say hello.
Hello.
And Adrian, would you like to introduce yourself?
Sure, yeah. Hi, everyone. I'm Adrian. I'm a designer and artist based in Los Angeles. Yeah.
Great. Thanks. So we have a tutorial. And would you like to,
Cool, yeah.
Take it from there?
Yeah, so we're gonna start with a really quick photogrammetry tutorial. We've been talking about like the beginning of project 3 and like how you guys can capture the shell from the end of project 2 is probably through a photogrammetry process. I think Adam was saying around half of you guys are in Leah's seminar, so you've done a good amount of that already. So I'm gonna kind of breeze through that, and then Adrian and I are gonna show you how you can take photogrammetry meshes into Blender and then blow them up and inflate them and play with like soft body physics in that environment such that you can export them back into Rhino as like a hard shell that then is your building proposal that you're infilling. So yeah, let's get into photogrammetry. So the software that I'm using, also I think Adam, did you forward this?
Sharing your
this drive folder? Yeah, I am.
Okay. You are?
Yeah, I am. What do you mean?
I don't think. But to record, it's on Zoom.
So
right.
Share it on Zoom. I see. I forgot.
Yeah.
Yeah, let's do that. Okay.
You have to open Zoom and yeah.
I've used Zoom before. Okay, thank you. It's been a minute. Oh my God.
You have to make it click on the green button.
Thank you so much.
Click on that.
Okay. All right. Share screen.
Nice.
All right. Okay. Did Adam forward you guys this drive folder?
I sent you a link on Slack.
Okay, so this just has outlines of everything we're going through today as Google Docs, and then all associated files are in there as well. It's not super important that you guys use those specific files, but if you ever need them, they're in there. And so the photogrammetry software we're working with is RealityCapture. I think that's the same one you guys have been using in Leah's studio, or we're using Metashape. No, fully a different one. Okay, so we're going to go through RealityCapture. I find that it's really useful because it immediately exports closed meshes, so you don't have to treat them and you can just start blowing them up and playing with them immediately. You have a little bit less control than Metashape, where you can edit the point clouds that come in, but I think for your guys' purposes, this should be the fastest, which I think is maybe the most important. And so there's two ways you can do photogrammetric capture. One is just taking a series of photos of an object. And I can demonstrate with Adam's water bottle, if that's okay. Basically just going in a circle around the object at a kind of equidistant radius from the center of it, one or two passes closer and farther away. And you can either, as I said, do that as a bunch of photos or do it as a video and then import it into the photogrammetry software. You can like pull stills from it. And so I'm going to go through both of those methods now. So this is what RealityCapture looks like when you open it. The one thing about RealityCapture that'll come up as I go through this is it's like a pay to use software, but it ends up being like 10 cents or something per capture, and it's really fast and powerful. So I find that the cost value analysis equation works out well.
Has anyone used this software before?
Yeah. Okay.
Just the song.
Okay. But it's very easy. 10 cents is 10 cents.
You pay per scan, and you don't have to pay anything to preview anything. And you can download the software for free.
Yeah.
And before you want to pay for it, you can keep scanning it as many times as you want.
Yeah.
But to download the scan, you have to pay for it, and it's not expensive. It should be a couple dollars at most.
Yep, perfect. Okay. So first we're going to go through importing a set of photos. So I have sample files already prepared in the freeze photogrammetry subfolder. And you essentially just click through. This is only like, 16 or whatever. For really dense photogrammetry cloud, you might take up to 200. But we'll see what it comes in like here. So you see you imported the photos as a series. And my computer will probably be loud, sorry. And then the first step you do is you just align the images. You can, perfect, super fast. You can do it with different levels of like degrees of resolution. I just did a very fast one now because I don't want my computer to freak out. But if you find that the mesh is a little screwed up, you can try doing it at a finer degree of resolution. Once you get this point cloud, you'll calculate the model to produce the mesh. Again, I'm just doing it this fast. Capture, so we're not here for a really long time. You got these white dots down here. You'll see where it's like seen the camera position from. Yeah. I have. I do. I do. I was gonna do this photo and then the video. It's almost done. Okay. Okay. Amazing. We have a mesh, and then the last step, you truly only have to click like 3 things, is to add texture. And again, we're gonna might set an arc time, like 40 seconds while it does this.
Greenhouse,
Boom. Okay. Amazing. So fast. And then to export, you just press export. And then you'll do it as an OBJ. It'll package it with the material file. But you'll see when you go to do it, it'll prompt me to pay for it. But I've already do that. I'm gonna save my 10 cents. But I have the sample export files from this process in that Drive document. And then let's do this again with the video. And I'll show you the sample video that I took for that. Okay, so I took like a little 30-second video. Flashy. I didn't even do it very well. My hand is not steady, the lighting's bad, etc. But it still comes out all right. Ideally, don't have as shaky hands as I do, and the lighting is quite even. That's something to note as you guys are doing this. Adam said that there is a photogrammetry scanning lab here somewhere, but it might be too small for your guys' projects.
yeah, I can do it for small things like this, but not
Okay.
for scale things.
Right.
They just have a little rotary table.
I see.
They just turn this rotary table and it's like 16-inch diameter.
So to import the video, you do a video sequence. I import the video, and then the only difference is that you'll say like how many still frames per second it's extracting to create the photo set. So I think I did it like every half second or something, or quarter second. So you get a slightly bigger set of images than the first one that I did. If you really want a very good mesh, you will slice it a number of times and have higher quality settings. But that also slows down what we're going to be showing you guys in Blender. the align images, calculate model, texture here, because we would sit in our zones for like 20 minutes, but I'll open the file of what it looks like at the end of that process. File is corrupted, but I can import the OBJ into Rhino to show. Other
That's not it.
That's not it.
That's not what came out. It's completely different. Yeah. That's nice.
Yeah. Big fan.
So the photo that's in the video that just has a little bit.
Yeah. The Photogrammetry Studio and the Computer Stock only works for small things because they have a series of fixed cameras that are surrounding this turntable. I can assure you that the results of this video
Yes, I did
saw
send
that
Adam
earlier
a
today, and I
photo
was
of
like,
it.
oh, that worked really well. So maybe
Yeah, I think we're gonna move
trust
on to the
that
next
it
thing.
worked. It was actually a really good. Yeah.
There we go. Okay.
Oh, that's yes. What is your question?
I see. Right. I see. Yeah, if you
just
can
have to-
start being far enough away from it that you can see the whole object as you're circling it, you can do successively closer circles.
You want to, for larger objects, you want to be able to get all sides of it and the top. Right?
Yep.
So, like, you could place it in here and stand on the steps and get a picture from it from the top, right? You can pull in all it does with the video is it takes the video and it breaks it into a bunch of pictures. And so it's just a bunch of pictures from different angles. So you can actually do a video of it and then do another video of it at a different angle, right? You can pull those two videos together to make the model from. You should try to do that, but you can have different distances to it.
Yeah. So like when we were in the software and we were importing a set of photos, you could have just done that a few times. For instance, if you took a few sets of images or if you took a few videos, you're just importing all of them. And then when you click align images, it'll intuit like where your camera position was. But there's Link. And I think Adrian, if you're still there, if you want to screen share over me now, we're going to start getting into some Blender stuff.
Sounds good. Cool. 1 second. Yep. Okay. One more second. Okay. Everyone can see my screen, right? I've got Blender on the right and this Google document on the left.
Yeah.
Cool. Okay. Yeah, so we'll go over Blender really quick. Just the intro, I mean. And if you, and if you need to like jump in, just make sure that I guess you speak closer to the mic, because I think I noticed that in the RealityCapture tutorial, I couldn't like really hear you very well. So if there's like anything you need to jump in and talk about, feel free to do so. So yeah, we're just gonna go over Blender and then do a tutorial of Blender, how inflatables work, how photogrammetry works. And at the end, we'll have a period where everyone can feel free to ask questions. And I think maybe, Ian, it would probably maybe good if we like, if they had questions about how to like integrate it with the overall studio project, we could show them various ways in which they could do that, I suppose, if we have time for that. So yeah, so this is Blender. It's a open source, free, completely free, 3D software toolkit that can do pretty much anything, you know, from VFX to motion capture, animation to physics. And today we're going to show you how to use it primarily for physics, for inflating models, photogrammetry models, or just basic models, anything in 3D space. We'll just show you how to inflate it or deflate it. So that's what we're going to use Blender for today. If you guys look at this Google document at some point later on, you'll see that we've provided a list of useful shortcuts for you. You know, various commands that are useful when you're navigating or trying to use Blender. And then I'll briefly go over like a system map, like the interface of Blender, so you can kind of get acquainted with it, especially if later on you go through the guide on your own. There are points in which we say, oh, go here, go to this area, go to that area. And then if you look at the system map, you'll know what we mean, because there'll be names associated with it. And you'll understand like where to go, where to access that command, in addition to some images we provided, some screenshots in the guide itself. So yeah, so this is Blender on the right. And you can see that there may be roughly a few basic portions to the interface. You've got this top bar here, where you've got file, edit, render, basic things that you're familiar with in other software, as well as a bunch of tabs accessing different workspaces. These workspaces are just different views of Blender. I mean, it's all Blender, but like they're more tailored to specific functions. If you need to like animate, if you need to composite, and so on and so forth. The splash screen, I just exited out of it. It's just as any other software has it. And at the bottom, you've had this thing called the status bar, which is just showing the status, various information about the things in Blender. And then this big area, this green thing in the window is just your areas. And then we have another map just to break things down a little bit more. As I said earlier, these are your menus. These are your workspaces, which we probably won't use at all, but just so you know how Blender is. On the middle here, we've got our 3D viewport. Similar to any other software. I think Ian will go over this more in depth later when we animate and inflate things. But yeah, it's just navigating around. You hold down the middle mouse button to rotate, and then shift middle mouse to pan. Again, I think Ian will go over this again shortly. On the right over here, we have the outliner, which is basically just like your layers. In Rhino, it's got all of the objects in the file. And then the most important thing is here on the right, this properties editor. It's just a window in which you access all your properties, where you can access modifiers, you can access physics properties, you can edit geometry, you can render. This is your hub, and we'll be referencing it a lot during the tutorial. At the bottom is the timeline. The timeline is how you animate things. So very similar to any other animation software, if you're familiar with it. These are just different points along the, I guess, the time during which you animate something. And then, yeah, and at the bottom is the status bar. So that is the basic gist of Blender. And if you have any more questions during the tutorial, feel free to reach out. And then the last thing that we need to go over is the glossary, which you can reference again at your own leisure later. But the basic idea is when we talk about a cube, it's just this base cube that Blender opens up with. There are a few things like a 3D cursor, which is just like the origin point essentially in Blender, but it can be moved around as a reference point. If you need to like snap it to something, it can actually be moved. And then there's an actual world origin right here, familiar with from other software. There's a thing called an origin that's different from the other origin, which is like a reference point for each object, this little orange thing. And then there's an empty, which we'll go over later at some point. And then there are things like keyframes. Just ignore all the other things I'm doing, but just look at down here. You've got like this rhombus shaped thing. And these kind of just, they basically are like markers that denote that an object should have a certain properties, like a certain location, a certain rotation, a certain scale at a specific point in time along the timeline, so that like between different keyframes, the object will transform in a way where it reaches the properties set by each keyframe by the time that it reaches that keyframe. And again, we'll go over all of these things later, and you're free to look over it on your own at your own pleasure after the class. And I think, Ian, I'll pass it off to you to show them the basics.
Well, yeah, so I'm just going to take you guys using the base cube that Blender starts out with, how you can begin to inflate and collide and deflate things. And then Adrian will take you through pulling in a photogrammetric model and doing those same operations, but it's just faster and more lightweight to start with just playing with this cube. So I will screen share again. How to do that. And so this is the interface that Adrian was just walking you through. And what we're going to do, we can delete out the camera and the light source that start with the software. The first thing we'll look at is going from object mode to edit mode at the top here. You'll see when you change from object to edit mode, you can also do it by using the shortcut tab. You'll see the vertices and control points that like construct the geometry. And right now that's not enough to run a kind of simulation. So the first thing that we have to do is have a greater density of points to the mesh. There's two ways of doing that. I'll take you through one now, and then Adrian will take you through one later. Also, I think maybe Adrian didn't show you that there's a gumball analog in Blender over here that allows you to move and rotate things that I find easier than using keyboard shortcuts or sticky keys. But at first, in order to remesh with a greater density of control points, we will go down over here to the little wrench, which is the modifier properties. Just click add modifier, and then in the second column, generate, about the middle, you'll see remesh. And we will shift from voxel, which is the one that it comes with standard, and go to smooth, because it already makes things a bit softer, which is nice. We'll click on smooth shading as well, which just changes the display properties, so you're not seeing stuff in a pixelated way. And then up here are the different viewport shading options that are essentially the same as like wireframe versus rendered in Rhino. If we click over to this viewport shading, we'll see now that it's much denser, and we'll actually make it even a bit more dense to 5. And so once we've played around with all of those settings, we'll just apply that modifier, and we tab again. We'll see there's now a greater number of vertices. But now that we've prepared this geometry, we can just start to play around with simulation settings. And so we'll do that in the physics properties tab, which is the circle orbiting a circle that's just 2 beneath the wrench that we were looking at before. And we'll flip the cloth. And so once we click the cloth, the dialog box will come up with a bunch of other settings. The one that's important to us for inflatable purposes is pressure. The pressure is related to the number of vertices that the thing has, so it won't be the same for every object that you're using. Right now, let's put it at like 1.5. And now we can just sort of see, I'm gonna move this so you guys can see the timeline a little bit. We're just gonna see what happens now that we've applied that physics simulation to this object. So you can either start the simulation by going down here and clicking play animation, or you can just use spacebar as a shortcut. So amazing. So it's blown up and it's fallen through the floor. So let's say we don't want it to fall through the floor. So we have to add a floor first. We'll go up here to add, right next to object, mesh, plane. Once this comes into Blender has a really weird way of scaling things. You press S, and then you just drag the mouse away from where the starting point of the mouse was. So just do that a few times until it's bigger than the cube. And then we'll just run the simulation again. Oops, and it's still falling through the ground. So what we have to add is another kind of physics properties modifier to both of the objects. When I go and click on this and I have the physics properties tab selected, you'll see a collision modifier. We'll click that for the plane, and we'll also click that for the cloth. And then when we run it, it'll crumple on the ground. But it's, let's say it's not as buoyant as we want it to be, or something. Like it's not inflated enough. We'll go back under the cloth physics properties and make it like, run it again. Boom, it'll bounce up. Let's say, yep.
How do you add?
Yeah. Oh, sorry. Yeah, that's like. Oh, you have to have. Oh, sorry. And now you're like 72 frames into the animation, so just go all the way back to the beginning. Yep, and then click it. Yep. Sorry, this is maybe a good time to pause for any other questions.
How did you add the floor?
Yeah, sorry. Okay. So you go add up here by the object mode, add, mesh, plane. I mean, it could be anything. Plane's just an easy geometry to start with. And then again, to scale, while it's selected, you'll just click S, and then you'll drag your cursor around and you'll see the preview of the geometry getting bigger.
There's also a scale thing on the left where you rotate and gumball are.
Yes, true. Yeah. Where's that? Here. Scale. Yeah. Oh, that's because you're in the middle of this. Sometimes when you're in the middle, you're running again. But now it was, yeah. I'll show you how to. Okay, any more questions? I'm gonna keep going. Yeah. Okay, so now we've seen what it's like when something hits something else and it has different degrees of pressure. Let's say we have an object and we want it to like shrink wrap or suck in on itself like we did in flow. So what we would do, again, go back to the beginning of the simulation, is we'd make it like a negative pressure. See the box. So, but let's say we want something to be like actually buoyant, like pretending it has helium in it or something. The way we would do that, put this back to the setting, is to change the density of the fluid under the pressure settings. Right now, the default is 0. We're going to make it negative like 0.0 and see if that works. We might have to toggle the value a bit. But essentially what that means is that the fluid inside of the object is a negative density, so it shouldn't float up. It needs to be more. There we go. Okay. Now we have the jellyfish from SpongeBob. Okay. Are there any other kinds of interactions you guys might want these inflatables to do? Adrian's going to take you through a few now, in a second rather. But one thing that is useful to know as well, like let's say you come in with a really complex, very specific object and you want it to more or less retain its shape when you run a fluid simulation on it. Further up in the cloth settings, there's something called internal springs. And if you turn internal springs on, essentially what they are is Blender arrays a bunch of internal tension cables inside of the object that resist the surface moving away from its origin point. When you run that and you have, let's see if it'll happen this time, when you have a lot of pressure applied and you also have a complex object, the surface will begin to ripple as if there's actual kind of cables inside. Okay, you see how it's just kind of retaining its shape as is. That's a kind of useful command if you don't want to get too floppy.
Yeah, if you like want it, you want it to fall, like you want it to fall, but without like changing, right? Because by default, objects, if you animate them, they won't fall. But if you give them a cloth property and then internal springs and stuff, then they'll fall.
Right. And then similarly, you can change the object's stiffness and dampening qualities. Like if it's just too floppy or not floppy enough, you can have it like, let's make it really not stiff. It's really not stiff. No, it's really,
That's lovely.
yeah. Whereas if we change these values to and the collision will the collision will continue to work even if you have the thing fly up. Oh, I didn't do it. So you can trap things on the swim.
But only if you're using a plane, like a single-sided surface, under collisions for that surface, you deselect single-sided right there at the bottom, right?
Under the collision settings.
Yeah. And then make sure single-sided is selected.
Okay, so I think, Adrian, is this a good time to transition now to like pinning and stuff like that?
Sure. You could show them how to collide two cubes, maybe like a inflated one and then a blobby falling one. That'd be cool.
I'll have one fall and one rise.
Yeah, and then I can do the pinning.
No plane. I'm going to add another mesh cube. So I'll go through the process of remeshing again. Again, it's under the wrench. Add modifier. I prefer to do this smooth. Good. And then the drop down and apply while you are in object mode, not edit mode. So let's give this a class simulation too. Again, our properties. Let's give it not very much pressure, and let's make it really fluffy. Oh wait, I just forgot to put collision. It's not yes. Collision modifier, ink block modifier, collision modifier, ink block. So this is what Sylvia was talking about. Exactly. Smash. Oh man, they're getting really intimate. They are one now. That is a magic trick. They got, wow, I was not expecting them to. They're really all up in each other. That's crazy. Okay, so.
Did you show them the collisions, self
the collision settings? Yeah, okay. So you can change how things collide with each other while you have an object selected, and you go down in the physics properties to the very bottom to collisions. And you can change like the quality of the simulation, but also like the distance offset from a given surface that things will hit each other from, like a kind of force field. And if you find that things are like flipping through each other, we want to just increase that distance. So we put it at like 0.5 meters and 0.5 meters. They'll be like more afraid of hitting each other. Yeah. Oh, you see, they have like force field between them.
And then obviously less will make it so the collision is more accurate.
Yeah, exactly. Normally I keep the collision quality pretty low unless I'm like baking a final animation, because it can get quite heavy and I can do. But another thing that'll change how and I'll just do it for one of these, that'll change how the digital inflatable is behaving is if you turn on self collisions. So right now when it runs the animation, the fabric is never hitting itself. But if you turn that on, especially if you have very complex geometry, a lot more things will be sort of happening in that play. I should do it with the other one. And maybe we can do that when you bring in some crazier stuff, Adrian, because I don't know if it'll show too well.
Yeah, for sure.
But yeah, you can see that the surface gets a little bit more variegated because it's bumping up against itself.
Yeah, that kind of stuff. I think for inflatables, it's definitely, you can definitely see it, but it's most obvious when you have like cloth, like curtains or like fabrics or something, then the self collisions really becomes apparent. And then the distance settings, like the fact that if you put distance all the way at 0, it makes things accurate because the force field is essentially nothing. So things are actually like hitting each other. All of that becomes, I guess, more apparent.
Okay, I think I'll pass the baton to you now.
Oh, actually, yeah, the self collisions is obvious there.
That's yeah, you could see it pretty well.
Okay, cool.
Yeah, let's pin some things. Okay, I'll stop sharing.
Okay. Okay, great. Let's see. Let me share. So we'll go over. We're going to go over pinning now. So we're going to have a new forms of interactions. Essentially, how you ground like a ground inflatable. So like it's inflating, but you don't want it to go anywhere. You want it to stick to the ground. You want to put a nail in it. You don't want it to fly off away or anything. So it'll just like float around, attach to the ground, or attach. Later on, we'll show you how it attaches to anything, like attaches to other inflatables, how basically how you can control your inflatables a little bit more precisely. So the first thing we're going to do is essentially just rehash what Ian went through in the beginning, the basics to making a cloth, making an inflatable, and then just like maybe like a slightly different method of subdividing it, but the same method of making the cloth. So again, this is the base cube that you see. What we're going to do is we are first going to go into edit mode, which is in the top left here, edit mode, or hit tab on your keyboard. And then this obviously object mode is where you just modify it as an object, animate it, so on and so forth. Edit mode, where you can edit points and faces, more detailed components of the object itself. So we are going to have everything selected. Make sure if nothing is selected, you hit A on your keyboard to select all. Double A is deselect, and A select. And then right click, subdivide. And so this is the same thing as remeshing, but slightly different. And then at the bottom, don't click out of anything yet. If you've lost this window, then just undo and redo it, redo the subdivision stuff. And then so you open this little window, and then under number of cuts, we'll set it to 20. And so you can see it's subdivided all of the surfaces into 20. And then that is how you subdivide it. And then if we go to the same little viewport shading method that Ian was talking about earlier, where you can see it in wireframe mode, you can see that it is subdivided. And then we'll tab or hit object mode to go into object mode, out of edit mode. And then you can do another thing, which is right click it and hit shade smooth. And if you're familiar with Maya or other solid modeling software, it's the same idea where you can see it, right click it, see it in flat mode, right click it and see it in smooth mode. And so that will make things a little bit prettier when you're inflating it, for example, because otherwise it'll be a little bit more pixely when it's shaded flat. And then this way it'll be smooth, like a real balloon. So that is the gist, again, of subdividing. And then we will go into our modifier properties, or actually we'll go into our physics properties, the circle thing. We will add a cloth just to make it into a cloth. And actually, let me get this one out of the way. Let me actually have to delete this keyframe. Ignore that. And then this little button here to go to the beginning, because of course the physics properties, as Ian mentioned, is an animated thing. So we've got our cloth, and then we'll just go all the way down in the cloth window to pressure, select pressure, set pressure to 5, pressure scale to 1. I think fluid density like -0.1, I think would be good for this number of vertices. Yeah, and then let's press spacebar, and there we go. Floating cube. But now we want to control it. We want to stick it to the ground. You want to make sure it doesn't go anywhere. So how do we do that? We are going to do something called pinning. So the first thing we do is we go into edit mode, top left here, edit mode, and then hit A twice on your keyboard, AA, to deselect everything. And then we're just going to select one little corner on this cube, which is this corner. So you can see it's selected because it's orange. And we have to tell Blender how to denote this point as special, this point as being a point in which we control. So the way to do that is to go into this green triangle called Object Data Properties in the Properties window. And then you've got this thing called vertex groups. It'll just be a collection of vertices that are important for whatever reason, in this case, for controlling and pinning. And so under vertex groups, we hit plus to create a group that doesn't do anything with the point. It just creates a group to contain the point within. What's really important is to click assign, so that now this point is assigned to this group. Otherwise, it won't work. So make sure you press assign. We'll double click this group and we'll just rename it something for reference, like pin group. And if we click here in the space to deselect it, and then we click select under pin group, we can see that is now selected. So yeah, just make sure that point is selected. And then the next thing to do to make sure that it edits the cloth properties themselves is go to physics properties under cloth. We'll scroll all the way down. And then there's a little tab called shape. We'll click shape. Under pin group, there will be a thing called pin group. And then there's this black bar. We'll click the bar. And then we'll select the thing that we just titled pin group. And it should work. So let us go back into object mode. Tab on your keyboard or in this top left. Make sure your animation's at 0 or 1. And then just press play and then we'll see what happens. There we go. Now we've got a floating cube attached to the ground. Very fun.
We should maybe pause for any questions, or how are people doing with that one? That's a few steps. Good, we're good.
I started following a lot.
I see. Okay. All right, we're good to go, Adrian.
Everyone's good?
Yeah.
Okay. Cool.
You're doing great.
Thank you so much. Appreciate the encouragement. Next one is we are going to pin it to an object that moves. So let's say that the cube is like a kite, or I guess a balloon in a way, like floating on a stick. So we're going to attach it to some kind of stick, and then we're going to move that stick around. Now this diagram is getting kind of confusing. It's a lot of scribbly, but we're going to move that stick around, and the cube is going to move around along with it. So that it's not just something pinned to the ground, it's pinned to something that moves. So we'll see how to do that. Let me delete this annotations. Clear. Great. So the first thing we're going to do, just for posterity and just to make things clear and I guess not confuse the pin group with what we're about to do, is we're going to go back to this green triangle thing and then just hit minus on this pin group just to delete it. And we're going to do the same kind of thing again, but you'll see it'll be slightly different. So it's still a cloth. Everything's the same. We've just deleted the vertex. We'll hit tab to go into edit mode. And then just make sure that only this point is selected. And then we will click plus on this vertex group. We will make sure that we click assign to make sure it's assigned to that group. Make sure you click assign. We'll double click this one and we'll call it something different. We'll call it hook group, or what you're about to see. The command that we'll do is actually called something called hooking. So we've got this selected. We've got a hook group assigned. We'll go to physics properties under cloth and then scroll all the way down. And then under pin group, under shape, we'll select the hook group. So the same thing as last time so far, but something new. With this point selected, you're going to hit Control H on your keyboard, Control H, and then click hook to new object. So now we've hooked to a new object. It doesn't really look like an object. It looks like cardinal directions, a coordinate point. This is something that I mentioned very briefly in the beginning in the glossary. It's something called an empty. It is something that it doesn't render. It doesn't have any material. It's kind of just like a handle in Blender and like a reference object that you can attach things to. You can move things with. You can move it with something else. It's just like a handle, some kind of control point in a sense, but also kind of an object. It doesn't render. So that is an empty. So now we've hooked the point to the empty. So now wherever the empty goes, the point will go with it. So that's the kind of meaning of the hook. Like it's attached to the empty. It's like the child of the empty. It's kind of parented to the empty. To make sure that this works, we have to do a couple more things, which is go to the modifier properties, this wrench, where you can see all your other modifiers, including your cloth and remeshing, like Ian went over in the beginning. And the first thing we have to do is we have to click these little buttons, not buttons, but these little dots here, which essentially allows you to move modifiers. And the way the modifiers work is kind of like Blender calculates these modifiers in order. So it's hook and then cloth. And that's really important. It has to go before cloth just for the way Blender processes it. And then under vertex group, we'll select hook group. And that just makes sure that it's controlled by that same kind of thing. So let's go into object mode, and then we'll press play. And we'll see that it's attached. Just reset your animation really quickly, and then we'll press play again. But with this empty selected, we're going to hit G to move. And G is the same thing as your gumball. It moves things around. So we'll press play and then press G to move. Oh, it's not doing anything. Make sure you undo to set everything back to 0. Let's make sure that we've got everything set up properly. We've got this object as the hook. We've got the hook group. It's before cloth. Okay. Then let's see if we've got the hook group selected. Select. I wonder what happened. 1 second. Oh, there we go. I guess it just glitched for a second. But you can see that I'm moving the empty around, and then the inflatable is like flinging around along with it. It's just end the animation, and then hit Control-Z on your keyboard to reset everything. And then also shift left arrow or this button to reset the animation. So we're not doing that for now. What we're doing is we're actually going to keep everything as is and then attach the hook to an object. So the way to do that is we're going to hit add up here, mesh. We're going to make the flagpole or the string for the balloon. Go to cylinder, and we've made a cylinder here. Before we click anything, let's edit these settings, set the radius to, I think, maybe 0.1, the depth to maybe 5. I think that'll be good. Radius 0.1, depth 5, and now we've got a cylinder. Take the cylinder, press G on your keyboard, and then just drag it off to the side so that it's close to the point, the vertex point, but away from it. And the next thing we're going to do is we're going to snap it to that point. So the way to snap things is to go to the top bar here, this magnet tool, click the magnet to turn on snapping. It's blue. And then next to it, there'll be a little drop-down menu, and you can select what to snap to. So we'll snap to vertex right here, just so that we can snap the vertex of this cylinder to the vertex of the cube. Hit G and then drag it over to the point, and it should snap. If anyone has any problems with this, just let us know. It should snap just like that. And then the next thing we're going to do is we're going to essentially hook the empty to the cylinder. Or in a way, what Blender calls it is parenting. So we're going to set the hook as, not the hook, the empty as the child to the cylinder as the parent, or vertex on the cylinder as the parent. So that wherever the cylinder goes, the empty goes, but wherever the empty goes, the cylinder does not go. So it's a one-way relationship. So what we do first is we select the cylinder, just a cylinder, hit tab on your keyboard to go into edit mode, press AA to deselect everything. And then in the outliner, this layers window, select the empty. Select the empty by clicking this little button here, and then shift click a point, like this point on the cylinder. And then whatever you select last will be the parent. So you have to select it in order. And then Control P on your keyboard to click make vertex parent. And it'll make that vertex the parent of the hook. So let's see, if we move, as you can see, if we move the cylinder around, the empty follows. So now what we're going to do is we're just going to bring everything together and kind of make an animation just to show you guys how to animate things. I don't actually know if you'll need this for your project, but it's kind of a nice way to show you how things work. So we'll click the cylinder in at 1, press I to bring up this menu, I on your keyboard, click location, then go all the way to the end, maybe 230, hit I again on your keyboard, also hit location. Then let's see, let's go to 30 on the keyboard, hit G to move a cylinder anywhere arbitrarily, left click to confirm, hit I again for location, and then let's go to 120 or something, and then hit G on your keyboard, move it anywhere arbitrarily, and then hit I on your keyboard and hit location as well. So now we've got 1, 2, 3, 4 keyframes. And if you drag along, you'll see the way that it moves. But let's reset the animation so the cloth has a chance to catch up. So I think we've got everything set. And then I think if you just press spacebar, oh, it doesn't work. I wonder why. Let's see. It should work. Oh, I don't know. For some reason, Blender's got some issues like that. But what I just did was I went into object mode. I had to edit mode on the cube and then select the hook group and then just confirmed everything and then exited out of it. And for some reason, now if we press spacebar to animate, it does that. Pretty fun. Like a little, like a lollipop, I guess. Yeah. I guess we can pause for any questions.
So this part of the animation process
Yeah.
is useful for getting different shapes
Mhm.
and forms. So this is like a way to generate new forms from existing forms. And you can stop the animation at any keyframe and you can export that frozen frame as a new 3D model, right?
Yep. That's
so
what
then
we'll
you
end on.
can use that as a basis for something. So this is something that I might encourage you to do for the final part. So when you're designing the building, you'll have a 3D scan of your furniture, and then you can decide to do various magical physical operations to that 3D scan to generate a new iteration of that form at a building scale. So, but you won't have to make that physically. So you can kind of have more creative freedom for what you do. So like maybe you inflate one part and make the other part solid and make another part like buoyant or something. So that you don't have to totally just stick with the exact same form that you had from part 2. You can use these kinds of software to generate a new form and use your physical model as a reference. So this is the starting, this is like where that came from, you know, before we applied new physical content. Does that make sense?
That's also a great lead into the next part of the tutorial where we're taking in scans and then applying physical properties to them.
Oh yeah.
Yeah.
What was the solution when it glitched out? What is this a common thing in Blender? You have to switch it back to object mode to get it to work, or
Why did it glitch?
and how did you fix the glitch?
Oh yeah. The glitch, I don't know. It didn't happen to me before. Ever. It actually never happened to me before. But the way I fixed it was I essentially just clicked the cube and then I hit tab to go into edit mode. That might have been enough, and then to exit out. But then I just went to the vertex group here. I selected it just to make sure. Like it doesn't do anything other than helps me make sure that I did assign it. And then I just exited out of it, tabbed back to object mode, and then it worked.
Your comment was correct with like toggle between edit mode and object mode a few times, and that'll sort things out usually. So yeah, sometimes that'll just sort it out.
Because I knew like the fundamentals were right. Like I knew that it was assigned. I knew that it was hooked. I knew that it was attached. So like, yeah, I guess flipping in and out worked.
That's great.
Okay, should we show them some cows and violins now, Adrian?
Yeah, let's show them cows and violins. I think more that I don't know if you have time. Can I just attach a cube to another cube?
Yeah.
Let's do that.
I'm fine with you doing everything you need to do. Like you can take as much time as you need to finish this.
Mhm.
So yeah, do what you want to do. because that's
Oh,
great.
yeah.
But, and I also, if you have to go at any time, that's understandable.
Oh, okay. No, no problem. I'm happy to stay as
Class
long.
is like 5 hours long, so
Okay, well, we've got another 4 hours to cover then.
Yeah. I think this next thing that we're going to be showing of like pinning one inflated object to another inflated object will be useful for what Adam was saying of like you get the scan of your output object. Maybe you want one part of it which was soft in the physical thing to become hard in Blender or vice versa, and so you can give different parts of it different physical properties and have them interact in different ways. But yeah,
Exactly.
you can take it away, Adrian.
Sure, sure, okay. So this is pretty much just a continuation of the last thing we'll do. We're just going to delete the cylinder and replace it with another inflated cube essentially. But if it doesn't work for some reason because of like the chain of commands that we've done, then we'll just reset everything. But we'll see how it works. Usually for this tutorial, we reset everything. TMI. Let's just hit delete on your keyboard, or I guess if you don't have a delete button, hit X on the keyboard with the cylinder selected, and then X and then delete to delete it. Select your cube, hit Shift D on your keyboard to duplicate it. And let's just move it off to the same place the cylinder was over here. A couple things you have to do for just to clean everything up to make sure that it's a new cube, but still it's got all the properties. It's still cloth, it's still inflatable. It'll do all of those things. We just have to make sure that this little vertex here is not there anymore. So first thing we'll do is we'll go into the wrench with this cube selected, hit X next to the hook to get rid of the hook so it's not hooked to anything. Then we'll go to the green triangle, and then under hook group, we'll hit minus. So now everything is reset and we're solid. We should be good to go. Up here, we've got everything snapped. Vertices snapping still on. So just have your cube selected, hit G on the keyboard, and then hover over this point here, and then it should snap. So now everything is snapped. But we have to make sure that this point of this cube is pinned. So the first thing we'll do is just do the same thing we did before. Go into tab to edit mode. Select this point on this cube. Go to vertex groups under the green triangle, hit plus, click assign to assign that point to this group. We'll double click it, call it pin group, just to make sure we know what it is. And then that is pretty much everything that we need to do. The last thing that we need to do is just make sure that we connect the empty, that coordinate point, the thing that the other cube is hooked onto, and make sure that empty is the child of this point so that the empty will follow this point. I think vice versa works as well. Either way, it should be good. So let's just do that. We will, the first thing we do is hit double A to deselect everything. Hit this empty in the outliner. That's the only way to select another object while in edit mode for one object. Hit Shift, click on this point, and then do Control P and select Make Vertex Parent. And I think we should be good. So let me just see if that works. There we go. So now they inflate together. The last thing that we might want to do is select this cube under physics, the circle within a circle, hit collision. And then this one, do the exact same thing, hit collision. And if we animate it, they'll kind of like collide with one another and then inflate together like two pals.
Can we have one not be buoyant?
Yes.
Like different physics properties. Yeah.
best friend.
Best friends. Yeah. Now one is not going to be a best friend. One's going to be left behind, but one's going to drag the other down. So this one, let's say we'll turn the internal springs on actually, and then select the fluid density to 0. So this one will be rigid, and then I think it'll sink and this one will float. So let's see what happens. There we go. Sinking to the bottom of the ocean or something. But I think we can Oh, and I don't know if you noticed, but sometimes when I reset the animation, I hit shift left arrow key on my keyboard, you've got this kind of remnant here. Just hit Control Z, and then that vertex will be reset. It'll be okay again. And then I think we can make this pressure maybe 1. I think it'll make sure that it floats still. Maybe not. Let's see. Put the pressure to be 1 or maybe 0.5. And then this one pressure to be maybe 8 or something. Put us to be negative 0.2. Oh, very heavy. Well, you can tweak the settings and make sure that it works properly. But that's the gist of it. Should I do anything else?
Any other requests for our pair here? I think maybe we should get into cows and violins.
Great. We're gonna get into cows and violins. So let's just select everything by dragging over, hitting X on your keyboard to delete. We deleted everything. And now what we're going to do is we're going to import photogrammetry. So this will be super pertinent to what you guys are actually doing. So up in the menus in the top bar, we hit File. We go to import FBX here, or import OBJ. So the files that we sent to you guys, the cow and the violin, those are all OBJ. So we'll just open an OBJ. We'll go down to the file here. We've got a bunch of files. Let's open the violin first. And then we're going to open the violin.obj right here. Great. We've got this huge violin. One thing you'll notice is that it's gray. There's no material. You can't see a material, and the back is open. I think, Ian, you mentioned that with RealityCapture, it exports as a closed mesh.
Yep.
Right. Okay, good. So that's fine. Then we won't have to do the thing that I'm about to do, but I'll show you in any case, in case you use some other method of getting a photogrammetry, or you find something online, for example, some point in the future, you'll need to close the mesh so that it can inflate. Otherwise, of course, it won't inflate. So up here in the top right, you can see if there's material there. We'll go to here to viewport shading, and we can see that there is no material attached. You can see that there's no material because it's pink. So that's usually what happens when there's no material assigned. So what we have to do here is, I think you guys shouldn't have this problem, but just to show you, I guess, we'll go to shading, this shading tab here. You've got this grasshopper looking thing here. Ignore all this other stuff. Just zoom into this thing on the left. Violin texture.png. This is familiar. We understand how images are referenced usually. We'll just go over here to open image, just to reference where the image is. And I've got it right here. I found the image, just open the image, and then we're good. So then you can forget all this other grasshopper looking thing, and then go over to the layout up here in the workspace, and that's where originally were. So this is the viewport shading, and you can see the material. So now we've got a violin material, everything is good. Let's hit tab on the keyboard to see all these points, make sure all the points are selected, because photogrammetry often does things in pieces. This is not actually one continuous mesh. So we'll hit right click, and we'll go all the way down to merge vertices by distance. It'll essentially just, you can see all these seam lines. It'll join those seam lines together, make it into one mesh so that it will inflate. And then the next thing we'll do is to close the back. We'll go to select the loops, select boundary loop, just select the boundary, the open boundary. Hit E on your keyboard, E to extrude, hit X on your keyboard to lock it into the X direction, and then just drag it out as much as you want and left click to confirm. And then I think we've got the boundary loop selected. So we just hit F on the keyboard to fill. And the very last thing we need to do is we need to break up the surface so that it properly inflates. It just needs to be triangulated and stuff. So up in the top here, you've got these 3 buttons. This one's got a point, this one's got a vertex, this one's got a face. Hit the face one, and then just so that you can select faces, select this face, right click, what was it? Triangulate faces right here. So we're just going to triangulate that, and then we should be good. So now we've tabbed out to object mode. We'll go under the physics properties to cloth, make it into a
And
cloth.
if you guys use RealityCapture, you won't have to do the 7 steps we just did to close the mesh, because it'll already come in ready to get filled with air.
But if you do it in RealityCapture, it's going to show up on a plane,
Yeah.
surface that you scanned it on. So like with the link doll, it was on a table,
Yeah.
and you have the table as part of the scan.
Exactly.
So you actually would need to cut away the surface that it's on.
Right.
Okay, I can show that with the cow, right? Because the cow is grass.
Yeah, exactly. Yeah.
We'll do that with the cow. That'll be helpful. So we've got this violin, and then pressure. Let's turn on pressure to turn it into this. And what was the settings that we set? I think, I forgot what we set for this violin, but I think it was like something like
I think
1.
it was pretty high. I'll pull up the doc.
Actually, I found it 0.001. It could be high pressure and then decent fluid density, or low pressure, decent low fluid density. And then if we just press inflate,
Yes.
a little violin plant kind of thing. So that's the violin. Now we've got a violin. And then let's bring in a cow, and then we'll link them together, and then they'll just inflate together or something. So we'll do the same thing we did before: file, import, obj. Let's go to the cow folder we found, import this cow obj. Where's the cow? I think the cow might be really small. Let's see. Yeah, the cow is smaller. So the violin is a huge violin. The cow is a very small cow. But when you import it, it's automatically still selected. So just press S on your keyboard to scale it, drag it out, hit S again if you need to scale it even more. We'll make it more close to the size of the violin. And then I think we'll just hit G on the keyboard to just drag it off to the side. And now you can see we've got this surface. So the surface might be like one of your tables or something. Probably won't go too deep in depth with it to clean up, but just show you the basics of how to clean it up. So we'll go to tab to go into edit mode. And then I think this is good because we're still in face select mode. So make sure that you're in face select mode in this top left here so that you can select faces. Just click to the side to deselect things. And then you can kind of just drag your window over vertices, or you can click, this is actually more advanced, but if you hold this box here, this little select box, and then you go to select circle, for example, there's different select options. You could kind of use it as a brush, just click and drag over it. And then we're just gonna delete some things like that. Like just some of this, not everything. Just things around the leg, for example, and then just hit delete or X on your keyboard, and then delete faces, just delete faces. We've got a lot of these remnants here. Actually, I should have done something before that. So don't do any of that, actually. I should have first gone to vertices, selected everything, right-clicked it, and hit merge vertices by distance. And then gone to face select mode, selected a bunch of faces, and then deleted them. And I think that also might solve the issue. So the other thing that we have to do here is let's go into select box mode. Just select a vertex, hit hit L on your keyboard to select everything connected to that vertex, and then hit I on your keyboard. Oops, Control I on your keyboard to select the inverse, and then we'll delete these guys as well. I think delete vertices. Yeah, so I guess we had some extra vertices for some reason. And you might have been able to avoid that if instead of deleting faces to begin with, we deleted vertices. But that has its own issues. So like that's an example of how you would delete some of the things around, like the table or whatever. And then we'll go into vertex mode, vertex select mode. hit A on your keyboard to select everything. Hit select up here in the top left, select loops, select boundary loop, and then E on your keyboard to extrude, and then Z just to make sure it locks in the Z direction or whatever you prefer. So now we've got this thing kind of separated that we can fill. Then hit F with everything still selected to fill. Go back to face select mode up here. Make sure that this face is selected. Right click, triangulate faces. And then now we've got a closed cow. Ideally, we wouldn't have any of this ground, but just for the purposes of time, I just deleted some of it. We'll make it a cloth. We'll set the pressure to, let's see, maybe 1, -0.001. Okay. See if that works. Maybe a little too well. Yeah. Okay. Well, it's a really inflated cow. I think maybe 0.5. Let's see. Okay, that's a more sizable, manageable cow. And so this cow's flying away. And there he goes. And then let's connect this cow to the violin. Where's the violin? Where's the violin actually? Uh-oh, might have lost our violin. Interesting. Okay, that's odd. The violin disappeared for some reason. This doesn't normally happen either. But we'll just redo it. We'll just get rid of the violin. Delete it. Then file import. I'll do this really quickly. Just to bring the violin back in.
Maybe instead of relinking that texture, we can just give it a different texture for the violin.
Okay. As in, just like the cow texture?
Yeah, like just give it a color from the, or give it the cow texture. Yeah, because maybe the students will want to not have one-to-one.
Okay.
Image maps of what they scan. Yeah.
Go to cow violin, right click, merge vertices, a distance, select, okay, great. Then I've got a cloth violin, a cow violin inflated, and I've got an inflated cow. And then the last thing we'll do is we'll just connect the two. So it's pretty much the same thing as before with the hooking, but you don't have to actually do the empty. I'll just show you like a shortcut. But because the cube, they kind of overlap, the points overlap, the vertices overlap when we want to link them. If you try to do it on your own, it's kind of difficult to select the right one. But here, you'll see. So hit G on the cow. We've got snap vertex selected still. So just snap the cow. Well, actually, let's move the cow down and then snap the cow like that. That doesn't really work that well. So maybe just turn off snapping and then just drag it however you like to wherever you want it to connect to the violin. And we'll do it like that. So the first thing we'll do is we'll hit tab on the cow. We'll select a vertex, go into vertex select mode, select this vertex, go to the green triangles, make a vertex group, assign it to that group, go into the cloth properties, under shape, select that group for your pin group for the cow. Then the violin will do the same thing, just select any point, maybe this point, go to vertex groups, make it a group, assign it, go to cloth, shape, set that pin group to this group. So now both are pinned. But the last thing we want to do is we want to go to tab on the cow, double A to deselect everything, and then hit Control on your keyboard, and then click this dot on your outliner next to the violin. And that is that little point there. Hit double A to deselect everything. make sure you select the same point. So this was the point I selected for the cow to be pinned to. And then shift click this point on the violin, then Control P to make it the parent. And then let's go back to object mode. And the cow will be parented to the inflated violin, and they should inflate together. As they do. Well, let me just turn on collisions really quickly. Vertex collisions, this one collisions, great. There we go. Yeah, looking pretty good, I think. It looks like a building.
It looks great. That's definitely a building. I think we've seen some buildings like that in LA.
Yes, quite a few actually, yeah.
Yeah, so that's cool. Do we have any questions about this right now?
I have a question about selection. Is there, when selecting vertices, is there a way to, because if you select on one side of the cow, it seems like it highlights what you can see. And then if you try to go to the other side, it isn't selected. Is there a way to select all?
Yeah, you change your viewport to the wireframe looking one.
Okay.
And then you can see everything at once. And then when you drag click it, it'll get everything.
Awesome. Okay.
Yeah.
Exactly. Good.
Yeah, maybe we should export this cow as a building and bring it into Rhino now.
Sure.
Let's pick a point in the simulation.
Let's do that.
I had a question. Is there a way to thicken the surfaces in Blender before you export them into Rhino?
Oh, like to get a wall thickness from
Yeah.
it?
Oh yeah, definitely. Let's try that. Let's make this the building, for example. So this will be the building. So let's just right click both of these two things. And then what you'll do is click right click, sorry, left click both of these two things, then hit right click, convert to mesh. So now, the cloth is gone, everything is gone. Now they are solid. If we move the animation around, they don't move at all. So that is our building now. It's solidified.
Good building.
And then we go to modifiers right here, this wrench tool. And then what we do is we go to, let me see, it's been a while. I believe it is solidify. Yes, solidify adds thickness. So let's see, let's go to, yeah. So we go into viewport shading mode. You can see, right, things are double layered. If we turn this off, you can see that it's the visibility turn off. You can see it's just a single mesh. And then if we turn on this thing, you can see that it's got thickness. And then the thickness you can add here, 0.01 meters, 0.05 meters. It'll be even thicker, a very thick wall, 0.5 meter. You can make sure it's an even thickness. That doesn't really work that well with something like this. You can make sure the offset is, I think, yeah, negative. So now it's 1. So now it goes in the other direction. Right? Yeah, it goes in the other direction. And then this one goes inside. It's all up to you what you want. I think you can play around with these tools. You can do only the rim, but just the default settings usually is good. So now we've got thickness, maybe 0.01 is good. And then this one also, because these things are gigantic, right? We'll also, let's see, where is it? Solidify, 0.01. Oops. Yeah, should have thickness. No thickness. 0.05. Oh, this one's really sensitive for some reason. Sometimes it can be like that. So just tweak it however you need. This one, it'll be 0.5 or something. And then mode, you can change it to complex or you can change it to simple. Complex is just more accurate. Cool. So now we've got thickness to it, and then we will just hit apply on these as well, or we can convert to mesh. Right click, convert to mesh. Great. So now we've got thickness to this kind of thing, these things, these two guys, and then we'll export it to Rhino. So right click, don't right click, select both of these guys, hit File, Export, FBX. And then what you want to do is you want to, there will be a tutorial in the guide that tells you the settings that you need, but you set path mode to auto, batch to off, limit to selected objects, turn off everything but mesh, just mesh selected. Z forward, so not negative Z, but Z forward. That's one thing you have to change. And I think that is it, except for maybe the leaf thing. Oh yeah, turn off add leaf bones under this. Don't bake the animation. I think that is that should be it, right? Yeah, that should be it. So we'll export the FBX to this cal folder. cal.fbx. Export it, and then let's try opening it in Rhino. Let's see, share. Cool. So now we've got Rhino open. We'll file import something. cal.fbx. Sure, do all that. And you can see it's got thickness. It shouldn't be upside down because we said Z4, but just rotate it however you need. Wrong way. Like this. Oh, interesting. This is usually not how it works, but I think there's some settings that if we have time to go over it, I can show you how to make things a little bit more accurate, but I had to manually adjust everything. But if we go into I think rendered mode, we can see the materials. I think if you add a clipping plane, vertical, you can probably see the thickness. There we go. So you got thickness here.
Yay, it's a building.
The building, yeah. So these are your elevator shafts, some egress, and
Yeah, easy, right?
Yeah.
It's
So,
just a matter of who's going to pay for it. That's always the issue, but
exactly.
with enough money. There's no budget in this building, so I think it's all right. Yeah, so any questions about this process so far? Can you make 2D that in an easy way?
Yeah, of course. Like as a section?
Yeah.
Okay, yeah. Clipping plane, we're in front view, make sure the clipping plane is selected to front. Let's see, we've got all this stuff, and then we'll just do make 2D. Let's see, turn on the clipping plane intersections. That should be good. Rhino 7 is pretty good at making 2D meshes, right?
There you go.
There you go. Some cleanup to do, but yeah.
You got to do some work, clean that up. But everything else is pretty easy to do. So, all right. That was really great. Is there anything else you were going to share?
Ian, is there anything else you think?
I mean, there's other ways of exporting without meshing them, but I think this was fine. Like just pick your keyframe, export, done. If for some reason you wanted like to have a bunch of different iterations of something inflated, I can show them how to do that without like baking the geometry.
Yeah, that would be cool.
So like, let's say like we really like frame 10 or whatever, but we can't decide between frame 10 and frame 30 or something.
You have to share your screen.
Oh, right. How do I do that again?
Zoom.
Where is Zoom?
Share screen.
Thank you.
You're doing great.
Okay.
Doing great.
So without like canceling the simulation, you can still export stuff. So like it's just file export as FBX. It's my best. You can export the next one too without stopping your simulation. I think other than that, yeah, I think that was the full Inflato tutorial.
Great tutorial, thank you. Yay. Any other questions from the students today? Can everyone say thanks? Whoa. Here's people. There's some people.
Hi, everyone.
Hey,
Having me.
hey. Thank you very much. Thank you very much.
No problem. I love your mask.
This is great. We've learned so much, and this is going to be very helpful. So I hope you have a wonderful day, and that you can make some nice buildings out of the things you showed us. Yeah, so cool. That's it. I'll talk to you again on the internet.
Yeah, talk to you soon. I hope this was really helpful. I hope it wasn't too long, it wasn't too boring. Everyone got everything, was entertained, they learned everything well, and hopefully it comes useful. And I'll look forward to seeing what the projects look like. Actually, see what they do.
Please, we'll have to invite you to view it in some format. Please,
Yeah.
Please do. Okay, yes. Have a lovely day. Nice to meet you.
Likewise.
Ciao. Bye-bye.
Bye.
Okay.